Hello, everyone. Thank you for having me, and for some reason your immigration folks actually let me in the country, which was kind of a mistake on their part, but, I'm not really going to question that too much. So, a couple of things as we get going with this. This talk is kind of a lessons learned and tools overview for what I've adopted to Zookeep, the capture the flag environment that I run for core security. And it's a simulated healthcare enterprise network. So it's a lot of VMs, a lot of configuration details, a bunch of stuff that gets knocked completely to hell every time folks play on it. So it has to be rebuilt every bloody time. So this is not about using DevOps in production. If it is, I'm sorry. If you've got experience using DevOps in production, you can go take a nap. And in keeping in my fine tradition of providing my leadership team with plausible deniability, this material has not been approved by marketing or any other responsible adult. Yeah, you know where that's going to go. So, hi, I'm Bobby Kuzma. I am a security researcher and product evangelist for core security. So I break things, I talk to people. I rack up way too many nights in hotels a year. So, hi, I'm Bobby, and I'm a hacker. Hi, Bobby. So, one of the things that came up as I started doing Capture the Flag events, and this started from an ISSA chapter going, hey, Bobby, could you build us a fake healthcare environment for us to go and fuck with? And they're like, okay, so I built it by hand. Big mistake. So this was kind of a roadblock for me because our executive team figured out I was doing it, and they decided, hey, you could take that to other places, and we could use that. And it could be marketing, and we could expose people to things. And we want you doing 3 or 4 of them a week. And I'm like, really? So before I let the door slam on that, I'm like, okay, so let's think about how we can do this. We could start with just snapshotting the things, right? Except if you don't run them for a while, Windows gets bit rot, and trust relationships blow up, and then you have those folks that will go to 2 separate events within a 6-hour drive, and if you don't change all the flags, if you ain't cheating, you ain't trying, right? So you end up kind of thinking, okay, so I could ask IT for help with this, but I don't want to wait 6 months for them to even look at the ticket. So, following my traditional problem-solving methodology, I did it myself. So, when we think about DevOps, normally you're thinking about doing the same things over and over and over again, really, really quickly, so that there's no, humans screwing it up in different ways every time. We want consistency, we want repeatability, all that fun stuff. So, when we're building a lab network, and it doesn't have to be for a capture the flag. This could be something that you're using for internal training for your team. It could be something that you're using for skills development within a class or with a user group, or passing it around amongst your buddies. You don't want to be shipping, multi-gigabyte VMs around across the internet, or God forbid on, SneakerNet. Okay? So, our starting point is we got to build images, right? So we got to start somewhere with a base OS and all that fun stuff. So there's a little bit of a philosophical question. How many times can you do the same Windows install before you go stark raving mad? It was about 50 in my case before I required a little bit of psychiatric help. And, there was medication involved in getting through that particular phase of the bad. So, as it turns out, because no problem in computer science or in IT ops has remained unsolved at this point, it's just a matter of knowing what tools have been built by some other poor bastard and being able to bend them to fit what you're trying to do, right? So there's this lovely concept of immutability that the DevOps heads like using. They don't like applying updates to things. They like starting with an OS that they know what's there and then loading their stack on top of it. And then when a new update comes out, they don't apply an update to it. God, no. They build a whole new OS image, update that sucker up, apply their stack, and then burn down all of the other stuff. Okay, so it's stand up the new infrastructure, test it, transfer the load, shoot the old stuff in the back of the head. You're done with it. You don't need to worry about it. You don't care at that point. So we've got this immutability thing going on. And, it's not necessarily frozen in time, but in my case, because we're simulating a relatively moderately okay managed healthcare network, which means nothing's been patched in years. I wouldn't want to put my medical data in there, which is ironic because guess what I seeded the EMR with? My medical data. So there's this lovely tool. It's called Packer. And Packer is really, really nice for building these base images without having to do all of that stuff. Now, probably the most boring thing that you can do in your entire life is troubleshooting an automated Windows install. Because we're going to tweak a line in the config, and then we're going to run it, and then we're going to go grab a beer, and then it's going to abort out because something didn't work, and then we're going to tweak the line a little bit more, and then we're going to run it again, and so on and so forth. Which is how I got away with buying a lot of really, really fast SSD storage. Because all of this stuff's I/O bound. It's a thing. So Packer uses JSON-based configs. And there's 3 different chunks of it that you have to worry about. Okay? So you start out with builders. And these are hypervisor specific. So you end up having, let's say that you've got, and if you've got devs or different guys doing different types of ops stuff, some people are going to be using VirtualBox, some people are going to be using Hyper-V, some people are going to be using VMware Workstation, some people are going to be using Zen, why I don't know. But you're going to have all those different hypervisors in play. And with Packer, you can have one config that generates out each one of those different VM types separately. So the builders take care of the hypervisor-specific stuff. Then you've got provisioners, which are common. And these can be copying files into the VMs. They could be running scripts. Doing all kinds of fun things. Doing reboots because, you can't really configure a Windows box without at least 45 reboots. Maybe 60. It depends on the version. Linux too, depending on how screwy the stuff that you're doing is. And then once you've got these built, you want to do things to these images. That's where the post-processors come into play. So these will do things like defragging and compressing the VMs so that they're going to take a minimal amount of space, packaging them up into virtual appliance files, or packaging them up into boxes for Vagrant. Okay, and Vagrant is another one of those lovely tools that not a lot of people outside of the dev space know a lot about, but it's something that you should know about, particularly if you end up screwing your box up routinely, like I do. IT doesn't like me. So, Packer, it's like Packer build and then the JSON file name, and then you go and walk away and then come back and you've got VMs. That's it. Okay? It's not this arcane set of commands that you've got to memorize to make this go. It's just Packer build what you're building. That's it. That's all you got to do. Now, this gets us our base stuff. Now, what if you're talking about wanting to spin up a lab type scenario on your machine itself? Let's say that you want to practice doing, SQL injection attacks on a realistic stack. And most people with a moderate clue about architecture are not going to be putting their database and their web tier on the same box. So you need to separate those things out. So we got lab on the machine. Vagrant is the lovely tool. Cross-platform. It abstracts away all of the nitty-gritty bullshit that you have to deal with standing up virtual machines from you. So it takes care of, among other things, this classic dev problem. And the classic dev problem is it works on my machine. Because, you got all of these dependencies that you can't reproduce from person to person, or, God forbid, from dev to QA to staging to prod. So everybody has a testing environment, whether you know it or not. Just some of us are lucky enough to have a testing environment that isn't production. So Vagrant starts with this canned format for beginning with a base virtual machine. It's called box format. And in your Vagrant file, and this is an example of one that I used. So at Black Hat, we had shirts that had hacker recipes that we handed out at our booth. And one of those shirts had a blob of hex vomit on the back of it. So it was shell code that if you actually bothered running it, it would connect up to a box and then drop some stuff on the machine and then tell you to come by the booth and talk to me. And then I'd give you like a year's impact seat. No one actually bothered doing it because I think folks at Black Hat don't like, trying to run random blobs of hex that they see on the shirt. I don't know why, but anyway, this was the dev environment that I used for that. So we're pulling down a specific box. So this is a canned Ubuntu box that is provided. Most of the flavors of the open source OSs, there's pre-built boxes that are maintained by the community. For Windows stuff, you pretty much have to roll your own and then put it up on a private internal repo for that kind of thing. But if you're rebuilding it with Packer, if you're building them with Packer using the eval ISOs, then once a week you do a build, and then you've got a 90-day bit with it, so it's all shiny and good. So with this, we grab our box, we set a host name, we run a script on it to do actual provisioning, and we set up the networking. And what's cool about this is we can go and set up relatively complex network topologies, just using the hypervisor that's on the machine, whether it's VirtualBox or VMware Workstation or whatever, which makes life really, really simple for this type of thing. And then when you run it, you end up typing Vagrant up, and then it goes and churns, and it might take a couple of minutes if it has to download a box from somewhere. Otherwise, it's just basically disk I/O that's getting sucked down. And it's really, really straightforward. And how straightforward is it? Well, the kid can do it and has done it because I don't let her run a persistent Minecraft server. She has to stand it up on her laptop. And that's how she stands it up on her laptop. Because, the home VM farms are busy running other things like Plex. Anyway, so what if we want to actually deploy and configure on more complex things, like we've got a ESX cluster or some other hypervisor, we want to spin stuff up in AWS. There's a lot of different ways that this stuff can be done. So we come across this fundamental rule, and is scripting sucks. Because inevitably, what started as a 5-line script for setting something out, because you've got all of these different ways that it can go horribly wrong and inconsistent, and that most recent OS patch breaks something in the middle of that. You end up with like 2% actual work and 98% error handling and exception management. So most provisioning scripts, by the time they get to a certain level of complexity, end up looking kind of like that. Or they start resembling, the IKEA bit, except, all of the labels have been removed because who the hell comments their scripts? So there's this word that we didn't quite invent it, but we borrowed it Okay. We stole it from a totally unrelated area of computer science. And it's a weird word, idempotency. So the simplest way I can explain this without a whiteboard and like 2 years worth of CS background is I want to declare that it shall look like this. And I don't care how it gets there from wherever it starts, but it must be like this when I'm done. That's idempotency. So this is the declarative way of looking at it. This is akin to saying, okay, here's the blueprint, what it needs to look like when we're done. I'll catch you later. Build it. So there's this entire ecosystem of tools that have sprung up around this that have become, again, very popular in certain circles because guess what? Humans are expensive and humans break and quit and go start raving mad. So, config management tools. The big four in that space are Puppet, Chef, Ansible, and Salt. Okay? So this is almost a split lineage. Puppet and Chef, built on top of Ruby, which I don't want to learn. Ansible and Salt built on top of Python. Okay, we use Python for all of our exploit code and impact. I know Python. That's cool. The other thing is that Puppet, Chef, and Salt all primarily require a binary be dropped on the target in order to do the thing. So you've got to put an extra piece of software on this. Now, I'm building systems that a bunch of hackers are going to screw with. Do I want to leave anything extra that I didn't plan on those systems? Probably not. So Ansible, its evolution was entirely agentless. So it wants an SSH or, in the case of Windows boxes, a WinRM connection in order to perform its configuration actions. Now, Puppet, Chef, and Salt do have agentless modes. They are not anywhere near as powerful as the agented mode. And despite my somewhat flipness about not wanting to learn Ruby, I did actually do a POC with each of these platforms before settling on Ansible. Turns out it's a lot harder to build a domain when you don't have anything to start with than programmatically than you would expect. So in Ansible, it uses a format called YAML. Yet another markup language, because we couldn't just use JSON or XML. We had to go and pull something else out of our backsides. So you start with a series of tasks and playbooks. And we start with where are we running it from? Well, we're going to provision a VM first. Okay? So we'll run this from the local Ansible box. And here's the beautiful thing with the Packer thing. I can actually build the Ansible master box for a particular CTF instance with Packer and then just drop it into the environment, boot it up, and then fire it off. So I don't have to configure that by hand at all. We go into our ESX, clone out the appropriate VM, set the network stuff, and then downstream, once it's started up, we can start configuring things on this box. And we don't configure them by saying, install feature or add feature or whatever. We do it by saying, we want to have a feature, we want to have GPMC, and we want it to be present. So when it runs, it goes, takes an inventory of the system, looks at that. And when it looks at that thing, it goes, okay, is this feature installed? If this feature is installed, then it's already present. We've met the state that's expected. We move on. Otherwise, it applies its own set of logic to figuring out how do I get from the current state, not installed, to the desired state, installed. And this can get pretty complex. Okay, who here has ever had to install an Exchange cluster? Okay. The entire process of building the domain and then installing Exchange and then populating the users and then putting content in their mailboxes is all done through Ansible in our CTF environment. We actually stand up an Exchange cluster in the simulated healthcare org. And some people have gotten it to send email to the outside world. That's about as fun as you can expect when I start getting ransom demands. Usually in the form of beer. So, as Ansible runs, we have our task, we've got some debug information, and then we have some color coding. Yellow means it's changed things. When we finished, it's recapped. We have things that were already good, we have things that were changed, and things that were failed. Move on, move on, move on. Okay, so this is all cool, Bobby, but why should I care, right? Well, I care very much, and my wife cares very much because I'm no longer spending a huge amount of time rebuilding this thing, but what's it look like? So, in our CTF environment, we have 20 target VMs, which include end-user workstations, 5 infrastructure VMs, and between 30 and 120 jump boxes that are what the players access the environment through. So we provide an isolation layer to keep them from fratriciding their laptops against each other. Because you know that that's going to happen if you don't have controls against that. 1,300 step checklist. Now, I don't know about you, but my eyes start crossing at about 200 steps, and then I start skipping them. Which means that things don't work downstream, which means I have to go back, which means I have to start it again. So turning this environment over was taking like basically a work week with me in front of the machine, and basically 70 to 80 hours of physical wall clock time, assuming everything was optimal at that point, to take the environment from nothing to fully ready to do an event with. Like, I like not working, but I'd prefer that my not working be, relaxing not working, hacking on something, not working because I'm sitting here watching a progress bar move slowly to the right. I'm not doing a forensic investigation or anything where I can bill that time. So when we do our Packer builds, we're building various flavors of Ubuntu and CentOS, Windows 7, Windows 10, servers 2008 R2, 2012 R2, building the Ansible box. I omitted, we've got a 2016 box, which is what the scoreboard runs on, because good God, I want to make sure that thing's on the latest code. Yes, people have popped the scoreboard. Yes, you get a special prize when you pop our scoreboard. We don't let you get all the flags that way. That's cheating. I appreciate that kind of cheating, but it goes against the spirit. It takes 60 to 70 minutes on this laptop to build all those VMs. That's it. I can do this, pull down a GitHub repo, as long as Packer's on the box and I've got a decent internet connection. That includes the download for the ISOs. 60 to 70 minutes. It can actually parallel a lot of that stuff. Once we do the deploy, it spins up the VMs, it starts building the domain, installs and configures the baseline software, drops the flags, builds the users. It takes about 2.5 hours, assuming I haven't screwed with any of the scripts, which I typically screw with the scripts. So there's usually at least one, oh, well, that didn't work. Let's re-roll that bit. So going from 80 hours with a full work week of me in front of it to I can do this in the evening before I fly out the following morning to the next event site. That's not bad. That's a pretty good and reasonable improvement. And I'm not having to schlep hundreds of gigs worth of VM images around with this. The base code that I have to start with, including like Packer and everything, is under 500 megs. And it's mostly, VMware Workstation, the hypervisor installers, all that crap. The actual config code that's behind this is under a meg. Under a meg. And put it up on GitHub, version control it. So I can share this with my colleagues. If, using the same bits, our support team, if they're having issues with a particular behavior, I can build them a quickie POC showing, yes, the product works as it's supposed to. It's something weird with the target environment. And they can share that with the customer and have them demonstrate that, yes, it does work. There's something jacked with your your space. So, when it boils down to, at peak, I'm running 2 or 3 events a week in different time zones with this thing. And because the majority of hotels, their internet sucks, can't do it in AWS, we bring hardware locally. It's the best experience. So, I'm typically shipping a pallet around within the US, and I've got 3 of them. So we rotate through. International stuff, it all fits in a Pelican that I can carry on, which makes customs fun. I have paperwork, really. But with that quick turnaround and those types, that type of cadence, one of the things I'm looking at with this is why are more organizations not using this type of thing for infrastructure stuff? And at this point, I have one conclusion that I have to be able to draw from that. Why are you doing things that you can automate? Why? I get it. If you have to use older Windows environments, up until Server 2008 R2, Microsoft didn't really grok the concept that people might want to configure things from the command line. So there's a reason why we only use from there forward in the environment, but it's one of those things. So with that, and I'm almost at 30 minutes. Awesome. So with that, does anyone have any questions? God. Yes, sir.
Did you speed up the Windows machines by using the core versions?
No, I want the attack surface available because that's I don't encounter core in a lot of production environments, so this is designed to be a fairly realistic, moderately mismanaged enterprise organization, and all of the vulnerabilities that I deliberately left in are things that I've encountered in the last 3 years on pen tests. So, the core isn't something I encounter a lot, and realistically, the time savings on that is not significant enough to be worth the change in the user experience on the playthroughs. Anyone else? Cool. Awesome. Thank you very much for having me.